Okay, today we're going to be talking about units of concentration that we use in chemistry. We have three main units of concentration that we use in chemistry: percent by mass, percent by volume, and molarity. Percent by mass is defined as the mass of the solute over the total mass of the solution times 100. It and the percent by volume are just percentages, and we remember that percentages are simply the part over the whole times 100. The part in the case of the percent by mass is the mass of the solute, and the whole is the total mass of the solution. A percent by volume is the volume of the solute over the total volume of the solution times 100. Now, typically when we're looking at these two, our solute here in the percent by mass is a solid. And our solute here is a liquid, so that we can have a differentiation between the two. Now, typical percent by mass solutions are things like when we dissolve solid sodium chloride into some water to make a percent by mass sodium chloride solution. Typical percent by volume solutions are found when you're looking at things like alcohol or the ethylene glycol, propylene glycol that you add to your radiator to prevent it from freezing. You add a liquid into a liquid and you measure the volumes of the liquids. Now these two are just simple percentages, as I said before. The main one that we're going to use in our chemistry class is molarity, and molarity is defined as the number of moles of solute per liter of solution. Now it may also be defined as the number of millimoles of solute per milliliter of solution. In these cases, or in the case of molarity, we're looking at not a mass unit, but a mole unit for units of concentration. Because remember, if we're looking at equations and balanced chemical equations, the concentrations that we use in there, or the amounts that we use in there, to balance our equations are based on the number of moles or the number of molecules. We can get to the number of molecules from moles, and we use moles predominantly in balancing those equations. So let's say we have a solution. It contains 54.6 grams of sodium chloride. Okay? This solution has a volume of 646 milliliters. My question would be to find the molarity. Well, molarity is equal to the number of moles per liter. So we have grams, and we remember from earlier that grams can be converted to moles by simply multiplying by the factor of 1 mole over that material's formula weight. And milliliters can be converted to liters by dividing by 1,000. So molarity will be 54.6 grams times 1 mole of sodium chloride is made up of 1 mole of sodium atoms and 1 mole of chlorine atoms. Sodium weighs 22.99 if we round to 2 decimal places. Chlorine weighs 35.45, so the weight of that would be 58.44 grams of NaCl per mole. And that gram would cancel. So that would be the number of moles on top, divided by 0.646 liters. Okay, remembering that in milliliters, there's 1,000 milliliters in a liter. So, molarity would be, in this case, 54.6 divided by 58.44 divided by 0.646. And we get a molarity that's equal to, we've got to have three significant digits, 1.45 molar. Now, if we were to take the same problem and find its percent by mass, the mass of NaCl is equal to 54.6 grams. If we needed to find the total mass, we would need to know the total volume of that solution and the density of that solution, and we would multiply the volume times the density to get the mass, okay? And that relationship there. So, in terms of ease of use and the amount of use, we're going to be using molarity more than we're going to be using these two percentages here. But just for your review, a percent is still a part over a whole times 100, and we can convert from a percent to molarity, and we can convert from molarity back to percent.